Today we will see the JEE PYQs of some basic concepts of chemistry, and today will be part 2 of it. We have already covered some of the JEE PYQs. So with this, let us start our class. Disclaimer: the images, text, and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at sathee@itk.ac.in, and we shall remove the content immediately. Please note that the parts of the content may have been generated using generative AI, which is experimental. So, I will request all of you to please stop chatting in the chat section. So, if there is an issue with the voice, I will check it. Apart from it, nobody will discuss anything except the class which is going on. Okay, so this is a very gentle request to all of you. So please stop this talking of sharing your personal IDs and all. Okay, so here is the first question. This question is to calculate the molality of 3M aqueous solution of NaCl. So density of the solution is given and the molar mass is also given for sodium and chlorine. And you have to use this data to calculate the molality. So your time to solve this question starts now. So most of you are giving the answer as B. So let us see what is the solution for it. Before that, I would ask all of the students to just write the correct answer along with some explanation. Okay. So I need some explanation because I'm having a doubt that how are you getting the answer quickly. Sorry for that, but still I need some explanation. So the correct answer will be option number B, 2.79. Mac, so for the Hindi version of the same language, of the same lecture, you can go and look at the website. Okay, so there we have the Hindi version of the same lecture. So first of all, what are the things that are given? We have the density and we have the molarity as 3m. So first of all, what we will know? We know that if the molarity is 3 capital M, it means 3 moles are present in 1 liter. So that is the basic meaning of the word molarity. So what is the volume of that 1 liter? It can be written in terms of ml as 1000 ml. The molar mass for the sodium and chlorine is given. It is 23 and 35.5. The molar mass of NaCl will be 58.5 gram per mole. What will be the mass of 1 liter of the solution? So if we know the density, if we know the volume, we can simply calculate the mass of that same solution, which will be density multiplied by the volume. Okay. Now in that mass, we have 1250 grams. So the 1 liter of a solution has a mass of 1250 grams. Now how many moles are being dissolved in the 1 liter solution? 3 moles are dissolved. So 3 multiplied by the molar mass will give you the amount of NaCl that is present in the given NaCl. Okay. If you do that, you will get it as 175.5. So here is a communication. So first we have to calculate the mass and then we have to calculate the number of moles. Okay. Yeah, you have to do that thing. Thank you for the explanation. So next we will get the mass which is of the NaCl. It will be 175.5 grams. So the mass of the solution is already calculated, and in that mass, the amount of solute is also calculated here, which is 175.5 grams. If you put all of these values, you will get the mass of solvent as 1074.5 grams. Now we have to look for the molality. How will calculate the molality? We know the number of moles of solute. We already know the mass of the solvent here, which is 1074.5 gram. The only thing that we have to do is to convert this gram into kg and put the number of moles on the numerator to get the molality as 2.79 mole per kg. Is it good now? Okay, so I guess most of you are getting the voice clearly. So some of you may be facing difficulty due to the connectivity issue. So just check your internet connection in that case. Okay. So is this question clear to you, all of you? Is this question clear to all of you? Okay, so yeah. So what is your doubt in this question? So let us try to solve it once again. What is given in the question? We are given with the molarity. So molarity value is 3 with a capital M. Okay, so this is your molarity. Then we have the density. Okay, we have the density as well. So if you are facing difficulty in these questions, so there may be a lack of practice, I guess, because I put my almost every effort to solve the questions previously. So therefore, I would suggest you to please go and attempt the DPPs. Okay. So I think that would be very beneficial for you. Still, I am trying to make you understand this question. So this is just a humble request. So just please go and attempt our DPPs. They are well equipped with our current lectures and will help you to say attain supremacy in the this chapter. Okay. So for DPPs, you can just go and visit our website. Just type Sathee there, and there is a section for JEE and NEET on the left hand corner. If I get time, I will make you see that DPPs also. So although the DPPs may be easy for some of you, but still it will help you to grasp the concept very quickly. Okay. Now coming back to the point. So our question was, the molarity is given as 3m. Yes, you can ask that in the live doubt solving session. No issues in that. And we have the density, which is 125 gram per ml. So these are the two datas that we have. Apart from this, we have the molar mass of Na, which is 23, and Cl, which is 35.5. So these are the given molar mass. Now, when we say the molarity is 3m, what does it mean? It means that 3 moles of solute is in 1 liter of solution. So again and again we are doing this thing. So I guess this point would be clear to you. Then if it is so, if you want to know what is the amount of solution in grams in this volume, then how we'll do it? So dense mass can be calculated in very simple way. So mass can be calculated as density multiplied by volume. So we are calculating the mass of 1 liter of solution. Now density is how much? It is 125 gram per ml. If I convert this 1 liter into ml, I will get 1000 ml. Now just multiply this thing. So it will be finally 125 into 10 to the power 3 grams. So this will be your mass. Okay. This will be your mass. So I guess it was 1.25. Density was 1.25. So if it is 1.25, we will get here 1250 as the mass. Got it? Now we have the mass of 1 liter solution. It is of 1 liter of solution. Okay. And in that 1 liter solution, we have 3 moles of the solute. So can we calculate the mass of solute in that 1 liter? Because given that we know the moles in that 1 liter, so mass of solute in 1 liter would be how much? 3 multiplied by the molar mass. And what is the molar mass? Since our salt is sodium chloride, it will be 23 plus 35.5. If you keep all the values here, you will get the mass as 175.5 grams. So I'm skipping the calculation part as we are lacking time here. So we know the mass of the solute in 1 liter, and we also know the mass of 1 liter of solution. So can we say that mass of solution is equals to mass of solvent plus mass of solute? Okay, so it's very easy to understand this concept because solution has solvent and solute only as the component. Now we know this, it is 1250 grams. Mass of solvent is to be calculated, so we keep as it is. Mass of solute is 175.5 gram. Then what is the mass of solvent? Just subtract this thing. You will get the mass of solvent as 1074.5. So till this point, is it clear? Okay, mass of solvent is simply the mass of solvent. There is nothing hidden behind it. It's very simple to, I think it is quite transparent, right? Mass of solvent is basically the mass of water, I would say, because water is the solvent here. Because we are given an aqueous solution. An aqueous solution will have of course, water as the solvent. So we have the mass of the solvent, and we are also aware about the moles which is dissolved in that solvent, that amount of solvent. It is given as 3 moles of solute. So molality can be calculated as 3 by 1074.5. Okay. So that will give you how much? So, but one thing is there, you have to convert this gram into kg. So multiply this thing by 10 to the power minus 3. Okay, you will get it as 2.79 mole per kg. So I'm not trying to put any, or I would say I'm not trying to put any formula on you. So I'm just doing it by the simple method. Okay, as simple as I could, because it is very difficult to remember all the formulas. I'm just going by the definitions. Yes, Gurpant, what is your doubt? So again, I am repeating it. We have the molarity as 3 molar. Now, if it is 3 molar, then why 3 molarity means 3 moles are dissolved in 1 liter of solution. So Gurpant, I guess you have to look back at the lectures where I taught what is molarity. So when I am saying molarity, it means 3 moles of solute are dissolved in 1 liter of solution. Now first we have calculated the mass of that 1 liter solution, which includes solute and solvent both. But we know that in that 1 liter solution, we have 3 moles present as the solute. So 3 multiplied by the molar mass can give you the amount of solute. Okay. Now the mass of solvent plus the mass of solute is equals to the mass of solution. Just put all the values here. You have 1250 as the mass of the solution, 175.5 as the mass of the solute. You will get the mass of the solvent. Finally, you need the mass of the solvent in kg. So you are multiplying this thing by 10 to the power minus 3 and putting the number of moles on the numerator to get the molality. I guess that now it is clear. Anyone has any doubt in this? Now moving on to the next question. So this is a question from the 2024 mains, which was asked on the 6th April on the first shift. It is given that the density of X molar solution is 1.12 gram per ml. Okay. While in molality, the concentration of the solution is 3 molar. So in this case, you have the molality and you have the density as well. You have to find the molarity of the solution. So your time to solve this question starts now. So I think this is same as the previous question. In this question, we have to find the molarity. Molarity is given already. This is from the NCERT section 1.10.2. The correct answer is B, which is 3. How will solve it? Now, if we are saying that we have to find the molarity, then 2 things are there that we need. First of all, we need the volume, and second thing, we need the number of moles. Okay. Suppose we have 1 liter of the solution and we are saying that X is the number of moles that is present in 1 liter, because it is given in the question that X is the molarity. And whenever we say that X is the molarity, it means in 1 liter of the solution, we will have 1 mole of the solute. Okay. So again, this is from the definition. I guess you don't have any issues in this. Now, if there are X moles of NaOH, then what is the mass of NaOH in X moles? So that would be very simple. It would be molar mass multiplied by the number of moles. So by doing this, you can get the moles of NaOH in that 1 liter. So I'm doing that same thing here also. Now in the next part, we have calculated the mass of that 1 liter solution. Again, we have the density, but we need to convert the density into gram per liter, or you can do the otherwise, which is conversion of liter into 1000. So what are we doing? We are calculating the mass of solution. We have the density, we have the volume. Just multiply both of this. So take the volume in milliliter. So in 1 liter, there would be 1000 ml. So 1000 multiplied by 1.12 will give you 1120 gram as the mass of the solution. Is this clear to you? Is this point clear to you? Yes, Gurupant, what is your doubt? Okay. Now, what we can say? We can say that we have the mass of the solution and what amount of solute is dissolved in that. Its mass is also mentioned here. It is 40 x gram. So what would be the mass of solvent? Again, mass of solution minus the mass of solute. So 1120 gram minus 40 x gram. Next thing what we can do? We can take the formula for molality. So molality is very simple. Moles of the solute. We have already seen that X was the moles of solute, and 1120 minus 40x is the mass of the solvent. But we are converting this thing into again kg by dividing by 1000. And this whole thing will be equals to molarity, which is 3. Now solve this equation. We have one equation and one variable. If you solve this equation, you will get X value as 3. So this question is just opposite to the previous question. Yes, you will get the link for this lecture also in the Sathee website. I guess day after tomorrow, if you check it on the website, it will be there. Okay, X is the molarity. Okay. Akesh, there is no such notes available till now for my lecture. If you want it, then you can rewatch this whole lecture and make notes out of it. I guess it would be very easy because the whole thing is a type of note only. I've just pointed out some important things out of it and made a note out of it. Okay. So there is a question, where is X coming from? So if you look back at the solution, I've already told, and it is given in the question also, that X is the molarity of the solution. What is X? X is the molarity of the solution. If X is the molarity of the solution, that means X moles are dissolved in 1 liter of solution. Therefore, we have taken the moles as X. Got it? Okay. Now moving on to the next question. The number of methane required to produce 22 grams of CO2 after complete combustion is. Now, the molar mass of methane is given. It is 16 gram per mole. If you want, you can read about this stoichiometric in the NCERT section 1.8. Okay. And also in the 1.10.2. So this was asked in the 2024 mains exam again on the 5th April in the second shift. So your time to solve this question starts now. Let us see the correct answer. The correct answer is B, which is 0.5. How we'll solve it? For that, we need the complete reaction. So I would ask all of the students to write the equation for the combustion of methane in the chat section. So what would be the equation for the combustion of methane? How we'll calculate it? Yes, so it will be CH4 plus 2O2 gives us CO2 plus H2O. Yes, very good, Pratik. It will be this equation. Okay. Now further, what can be derived from the given equation? To calculate the molar mass of the CO2, we will simply use the molar masses of carbon and oxygen, and it will give you 44 gram per mole. Now it is very clear from the reaction that 1 mole of methane is reacting to give us 1 mole of the carbon dioxide, which is 44 grams of carbon dioxide, because one mole has a mass of 44 gram. How it is coming? Again, from the calculation of molar masses. Very simple to calculate. Now what we have? We are seeing that in the reaction, 1 mole of methane is producing 1 mole of carbon dioxide. But what we have to calculate? We have to calculate the mass of methane that is required to produce 22 grams. Now, if 44 gram is 44 gram of CO2 is produced from 1 mole, then what is the mole that is required to produce 1 gram of CO2? So this will be 1 gram, not 44 gram. So what will be the mass that will be required to produce 1 gram of CO2? It will be simply 1 by 44. I guess this point is clear. So again I am repeating it. If 1 mole of methane is producing 44 gram of CO2, then 1 gram of CO2 will be produced from 1 by 44 mole. So Navreet, Mehak, Harpreet, so all of you, can you please stop chatting here? So if you do it continuously, then we will be obligated to stop the chat section, and in that case you won't be able to ask the question. So you must have noted this also multiple times, and this is the reason we stop the chat. So please do not do any unnecessary chat here. So are you getting this point? That from the reaction, it is very clear that 1 mole of methane is producing 1 mole of CO2. Okay? Or you can also say 44 gram of CO2. Then what is the mass of methane that is required to produce 1 gram of CO2? It will be 1 by 44. Is this point clear to you? So moving on further, what we can say that for 22 gram, it will be simply 1 by 44 multiplied by 22. So again, I am repeating it. Here it will be 1 gram, not 44 gram. So again, if 1 mole of CH4 can produce 1 mole or 44 gram of CO2, then to produce 1 gram of CO2, we will need 1 by 44 mole of methane. Then to produce 22 gram, it will be 1 by 44 into 22. Clear? So yes, CH4 is the methane. So any doubt in this question? So this is asked in the JEE Mains 2024. So if you are able to solve this question, then I think your chapter is almost undoubtedly clear. Okay. So moving on further. Question is saying that we have a sample of calcium carbonate and magnesium carbonate whose weight is 2.21 gram. If it is ignited to constant weight of 1.152 gram, the composition mixture is. So we are given with the molar mass of calcium carbonate and the magnesium carbonate. Your time to solve this question starts now. Yes, you can take the direct mole formula. Again, this is from the 2024, 31st Jan. How we'll solve it? Let's see. The correct answer will be option number C. Okay, option C will be the correct one. What is given in the question? That we have calcium carbonate and magnesium carbonate, and this whole mixture has a mass of 2.21 gram. So if we consider the mass of calcium carbonate as x gram, then what we can write? We can write the combustion of calcium carbonate as the product form will be calcium oxide and carbon dioxide. So we have already assumed that we have x gram of calcium carbonate. Okay, we have x gram of calcium carbonate. Then what will be the number of moles? It is very simple. Given mass by the molar mass is 100. So x by 100. Now according to the equation, we can easily say that 1 mole of calcium carbonate is producing 1 mole of calcium oxide. So x by 100 mole will produce x by 100 mole of calcium oxide. So is this point clear to you till now? Any doubt in this equation? So again, I am repeating it. We are taking the weight of calcium carbonate as x gram. Okay. Now, if it is x gram, then we can calculate the number of moles of calcium carbonate as given mass by the molar mass. So this will be the number of moles. Okay. Now, according to the equation, 1 mole of calcium carbonate is giving us 1 mole of calcium oxide. Therefore, x by 100 moles of calcium carbonate will give us x by 100 mole of calcium oxide after the reaction. Got it? Now next, what we have? We have magnesium carbonate also present in the same mixture. And the total mass of the mixture is given as 2.21 grams. If we have taken x gram as the mass of calcium carbonate, can we take 2.21 minus x as the mass of the remaining thing, that is magnesium carbonate? So it is according to the equation, Nandini. So if we are saying that we are reacting 1 mole of calcium carbonate, then we will get 1 mole of calcium oxide. So if x by 100 moles of calcium carbonate is being ignited, then that would give you x by 100 mole of calcium oxide. So from that way, we are saying that we have x by 100 mole of calcium oxide. Okay. So the triangle is representing the heat. Okay. So if we heat something, then we put a triangle upon the arrow to symbolize the burning. Okay. Or to symbolize the combustion. Now, next thing is what? Next thing, we have the magnesium carbonate. We have already assumed that we have x grams of calcium carbonate, and the total mass of this calcium carbonate and magnesium carbonate is 2.21. Therefore, the mass of magnesium carbonate will be 2.21 minus x. So this is the mass of the magnesium carbonate. Again, we are dividing the mass of the magnesium carbonate by the molar mass to give us the number of moles. And the equation is also saying that 1 mole of magnesium carbonate will give us 1 mole of magnesium oxide. Therefore, 2.21 minus x by 84 moles of magnesium carbonate will give the same moles of magnesium oxide. Is it clear? Are these two steps clear to you? Any doubt in this? Yes, Anurag, what is your doubt? Okay, so I am moving further. So this triangle sign is again for the heating purpose. Okay, so it is given in the question that we are igniting it. Igniting means heating it. So to symbolize the heating process, we put a triangle sign. As simple as that. Now, what is the weight of CaO that will be formed, or the calcium oxide that will be formed? We know that we have formed x by 100 moles. So the mass of CaO formed will be simple number of moles multiplied by the molar mass, which is 56 grams. So this is the weight of calcium oxide. And what is the weight of magnesium oxide? We know that we have formed 2.21 minus x by 84 moles of magnesium oxide. So if you multiply the number of moles with the molar mass, you will get the mass of magnesium oxide also. So you got the mass of calcium oxide and you got the mass of magnesium oxide. It is given in the question that after this reaction is completed, we have 1.152 grams of product. Now, you don't have to include this carbon dioxide as it is a gas and it will escape the reaction mixture. and we will be only left with the mixture of calcium oxide and the magnesium oxide. Again, I am repeating it. So this is the mass of calcium oxide and this is the mass of magnesium oxide. The total of this will be the mass of the product, because we are not considering the mass of carbon dioxide which is escaping the reaction mixture, as it is a gaseous product. Got it? Now we can just equate this whole thing and get our X value as 1.187 grams. And what will be the weight of magnesium carbonate? It was simply, we have assumed it as 2.21 minus X. So just put the value of X, you will get the weight of magnesium carbonate. So why I have written weight? So you can use the word mass also. In chemistry, we use them interchangeably. We don't have any issue with it. Okay, so you don't need to worry if you see weight and mass being used interchangeably. Yes, you can use both of them. There is no issue in that. So in physics, we have an issue with that. In chemistry, we can take weight and mass both. Okay, it's very simple. Calcium oxide is the molar mass of. So what is the formula to calculate the weight of calcium oxide if we have the number of moles? Navneet? Sorry, Sukhmanpreet. If we have the number of moles, then what is the formula to calculate the weight? So what will the formula to calculate the weight of calcium oxide if we have the number of moles? So it's very simple. Just multiply the number of moles with the molar mass. So molar mass of calcium oxide is 56 gram. So again, it is directly coming from our very useful formula, which is number of moles is equals to given mass by molar mass. Yes. So you have written it very correctly, Gurangi. So it will be number of moles is equals to given mass by molar mass. Therefore, given mass can be calculated as molar mass multiplied by the number of moles. Yes, these are the molar masses. Okay. So moving on to the next question. So this is a very good question now. Okay, so just listen it very carefully. You will see that it's a very good question. And question is saying that we have a metal chloride in which the chlorine has 55%. Okay, by weight. So we have already learned about the weight by weight concentration and we know how to calculate it. Now, second thing that is written is that 100 ml vapor of the metal chloride. So if we take 100 ml vapor of the metal chloride, then its weight comes out to be 0.57 grams. Two things are given here. First of all, the weight percentage of chlorine is given, or the percentage composition of chlorine is given in the metal chloride. Second thing, it is given that if we take the vapors of that metal chloride and if we take 100 ml of the vapors, then its mass at STP is found to be 0.57 grams. Then we have to calculate the molecular formula. So we have to calculate the molecular formula. Your time to solve this question starts now. So can anyone answer that what is the amount of gas that is present if we are taking the gas at STP and we are taking 1 mole of that gas? Anyone? If you are taking 1 mole of a gas and we are taking the gas at STP, then what will be its volume? Yes, so it will be 22.4. Very good. Okay. So we have to use that concept to solve this question. If you know this thing, then we are good to go. Let's see how we'll solve it using this. Correct answer will be B, which is MCl2. This is the formula for the metal chloride. Now, we know that the volume of 1 mole of any gas at STP is 22.4. Okay, so this will be 22.4. Sorry for this. So this will be 22.4 liter. Or we can write the same thing as 22400 milliliter. So this is the volume of 1 mole of any gas at STP. Now, next thing that we know from the question is that 100 ml of this vapor has a weight of 0.57 gram. Okay, 100 ml of this vapor has a weight of 0.57 gram. Now, what is the weight of 1 ml? It will be 0.57 by 100. Okay. Or we can also say that what will be the weight of 22.7 liter of the gas or 2 to 700 ml of the gas. So that will be simply multiplied by this given thing. But we know that this volume of the gas has 1 mole. Therefore, we can say that the mass of the gas which has a volume of 22.7 liter or 22.4 liter or 22,400 milliliter, it will have the molar mass of the same gas. Yes, it will be 22.4. Sorry for that. So this will be 22.4 everywhere. So did you get it how I am saying that it will be the molar mass? So it's very simple to understand. If anyone has any doubt, they can ask why I am saying it as the molar mass. Just try to analyze this calculation. It's very simple. So Navreet, I have converted this liter into milliliter rather than converting this milliliter into liter. Okay. So anyone has any doubt in this step? I guess it is very clear. Okay. So if you have doubt, you can ask it or I will move further. So that calculation will give you 127.7. Okay, yeah. So Garangi is asking that why molar mass. Okay. So very good. So we are saying that we know that if we take 1 mole of any gas, then it will have a volume of 22700 ml. Okay. Again, I am repeating it. If we take 1 mole of any gas at STP, then it will have a volume of 22700 ml. Now, can we say that the opposite of this will be also true? That if we take 22700 ml of a gas at STP, then we will have 1 mole of that gas. Am I true to say that? Yeah. So if that is true, so if we calculate the mass of the gas that is present in this 22700 ml, then are we calculating the mass of the gas that is there for 1 mole? Just try to analyze these two statements. First, if we are taking 22700 ml of the gas, then we are taking 1 mole of the gas. And if we are taking 2270 ml of the gas's weight, then we are taking the mass of that 1 mole. Okay. Got it? So, Niranjana, did you get this point? What I'm trying to make here? Yeah. So, we are getting the mass of 1 mole as this. And we know that the mass of 1 mole is simply what? It is the molar mass. Got it? It will be the molar mass. Now, what is the next thing that we can say? The next thing that we know is the mass percentage. Now, this is a very crucial thing. So, suppose the molar mass of the chlorine metal chloride is 1 to 9.39 gram. Okay. Now, what is the mass of Cl that would be present in that amount? It will be, of course, 55% of that mass. Okay. Clear? So that will be equals to 71.1645 gram. So the amount of chlorine that would be present in 1 mole of a substance will be 55% of the molar weight. And our molar weight is this. So if there is any issue with the calculation, you can just try it once again. So there may be an issue. Do not panic in that case. We will correct it as soon as possible. So are you getting this point? So if we know that in 1 mole of a gas, the mass is 129.39 gram, and we know that 55% chlorine is present by weight. Therefore, we can say that in 129.39 gram, we will have 55% as the chlorine, which is 71.1645 grams. Is this step clear to all of you? Okay, now moving on further. So, in 1 mole of this metal chloride, we have this much amount of chlorine. Then, how do we calculate the number of moles? It will be simply the mass of the chlorine divided by the molar mass of chlorine, which will give you 2 mole. So, Navreet, I guess it is given in the question that we have 55% of chlorine by weight. So, whatever weight we take, we will have 55% as chlorine. Okay, so if we are taking 1 to 9.39 gram of this metal chloride, then out of that 55% will be chlorine. Now, since we have the number of moles of chlorine, we can write the formula of the metal chloride. It will be simply MCl2. So what is your doubt here? Is it clear to all of you? Anyone has any doubt? So this is a very good question. So if you are facing difficulty, just try it one more time. I guess you will get it. So the mass of chlorine is, so that is the mass of Cl2, I guess. So 70.199 is the mass of Cl2 and not a single chlorine atom. Yes, the volume would be 22400. So how are we saying that it is MCl2? So 3 steps are there from which we are concluding that the formula is MCl2. What are those 3 steps? The first step is, we know that the mass of chlorine that is present in 1 mole of metal chloride is 71.645 grams. So I have written it by mistake. Sorry for that. I have taken the NTP condition rather than STP. So what I am saying, again listen to it. Why I am saying it as MCl2? Because we know that the mass of chlorine that is present in 1 mole of metal chloride, it will be this, because this amount is the molar mass of the metal chloride. Okay. So for the given metal chloride, the molar mass is 129.39 gram, and that is the mass of 1 mole. And in that 1 mole mass, we will have 55% chlorine. So that will give you the mass of chlorine in 1 mole of the metal chloride. Now, since we have the mass, we can easily calculate the number of moles. So molar mass is being calculated here. So maybe if we put 22400, we will get the same value. So no issue in that. You can take it as 127.68. Still you will get the same answer as 2. Just try it. Try it by yourself. You will get the same value. You will get approximately it as 2. Okay. You will get approximately 2. So no worry in that. You can take the value of 22.4 and that would be more correct. Okay, so just take it as 1 to 7.68, whatever you're taking. Put the same value here and calculate it further. You will get 2 moles. Now moving on to the next question. Next question is, hemoglobin contain 0.34 percentage of iron by mass, and the number of iron atom is 3.3 gram. In 3.3 gram is, you have to calculate the number of iron atom in 3.3 gram. 4 options are there. So this was asked in the 2022 mains exam on 26th July in the second shift. Your time to solve this question starts now. So maybe at some point I won't be able to clear your doubts. So for that you can just join our doubt sessions also, and you can rewatch my lecture on the website. It is present there along with the DPPs. Okay. So let us see how we can solve this question. The question is saying that if we take hemoglobin, then in that hemoglobin, the mass of iron is 0.34%. Okay. Then we have to calculate that what is the number of iron atom that is present in 3.3 gram. The atomic weight of iron is given and the Avogadro number is also mentioned. So see students, in most of the cases, if you see all the JEE mains question, just go back to the lecture, you will see every time that the atomic weight or the molecular weight is given. But for your internal exams, it won't be given. It varies from school to school. But at the JEE level, all of these values are given in the question itself. So let us not focus on the hemoglobin thing. Let us just consider just as a compound. You don't have to worry about it. Now, the correct answer is C, and we will see how we'll solve the question without finding that what is hemoglobin. Don't worry about it. So this is a very good suggestion for you. So if you see a tough question, just try to use the data that you know. Do not focus on the data that you don't know, like this hemoglobin. And you will see in the solution that we don't need this terms definition as well. So if we have 0.34% of iron, then we can calculate this amount of iron that is present in 3.3 gram of hemoglobin. So so again I am repeating it. So if you are not getting a point of any question, do not try to focus on that part. Try to focus on that part that you know. So I just assume that I also don't know that what is hemoglobin, but I know that it is some compound. Okay, some compound, and it is given that that compound is containing 0.34% of iron by mass. Okay. Now what if it is so, then what will be the weight of iron that will be present in 3.3? So we will simply take the weight percentage of that 3.3. Now if we know the weight, can we calculate the moles of that? Very simple. Given weight divided by the molar mass. Then if we know the number of moles, can we calculate the number of atoms? Yes, it's very easy. Just multiply that number of moles with 6.022 into 10 to the power 23. And if you do that, you will get 1.21 into 10 to the power 20 as the what? As the number of iron atoms. So do you have a doubt in this? I guess it's very clear. So first we have calculated the weight in 3.3 gram. Then we have calculated the number of moles in that 3.3 gram by dividing it by the molar mass. And then we have calculated the number of atoms by multiplying it with the number of atoms in 1 mole. Got it? Okay. Now this would be the last question for today's class. So we can't predict anything about this. So if you have seen the recent year NEET question, it was well tough. Okay. So you can't expect anything. Just prepare for the exams. Now, The compound A has 8.7% hydrogen, 74% carbon, and 17.3% nitrogen. Then we have to calculate the molar mass of the compound A. In molar mass of the compound is given, it is 162 gram per mole. We have to know the molecular formula and the empirical formula. So let us see how we can solve it. The correct answer will be C10H14N2. So it's very simple to solve. You have to look at this table and you will get the whole idea behind it. We know that we have 74% of carbon, 17.3% of nitrogen, and 8.7% of hydrogen. So there are simple steps to solve this question. The first step is to convert this percentage into carbon. So remember the step very nicely and you will be able to solve this type of question very easily. So convert the percentage into gram. Just write gram here instead of percentage. Now next thing, convert this mass into mole by dividing it by the molar mass. You have the molar mass given in the question, then you will get the number of moles. Okay, so this is the second step. Now out of this three number, 1.23 is the smallest one. Divide each of this value by 1.23 and you will get 5, 1 and 7. Got it? Is it clear to all of you? So we have the empirical formula as C5NH7 because for carbon we got it as 5, nitrogen as 1 and hydrogen as 7. Calculate the empirical weight using this empirical formula. You will get it as 81 AMU. Then get the multiplying factor, which is molar mass divided by the empirical mass, and its value will be 2. Yes, you have to divide it by the molar mass. Lastly, if you have this factor, 2 multiply it throughout the empirical formula. So 2 multiplied by 5, that will be C10. 2 multiplied by 1 for nitrogen, that will be N2. And 7 multiplied by 2, that will be 14 for hydrogen. Therefore, the molecular formula of this given compound is C10H14N2. So this was all for today's class.